This video is in preparation of the Chapter 1 Calculus test, which is all about limits and continuity. And so for this video, I just want to look at two problems, both that are piecewise functions. What you're going to notice when you start taking the test over Chapter 1 is you have piecewise showing up on every single page of the test. A lot of different ways that I can use piecewise functions to ask questions. So I want to show you two right now. What you'll see up here is a function made up of two parts, one function when it's less than or equal to 1, one when it's greater than 1. Here are the series of questions that I could ask. I could ask f of 1, the limit as x approaches 1 from the left, the limit as x approaches 1 from the right, and then finally the overall limit as x approaches 1. When you get the answers to the left side and the right side, that will automatically lead you to what the limit is at 1. So we're going to start from the top. The first is just evaluating a piecewise function. You take 1, you're going to put it into the top line because this is the equation that is dealing with when it is equal to 1. Put 1 into the top equation, you get 1 plus 3 minus 1, which is 3. So we know it's defined. I could also ask the question, is it defined at 1? Once you see that there is an or equal to that you can plug 1 in, you can tell that that is true. Second question wants to know the limit as x approaches 1 from the left. So you're looking for whenever it is less than 1. That again is the top line. That is the less than side or the negative side. We want to put 1 in. We already did that. We got 3. So in this case, those two answers are the same. Where it is defined happens to be the limit that I'll use to figure out what's happening on the left. Third question wants to know the limit as we approach 1 from the right, or from the positive side. Now we're going to look at the bottom equation, because this is the piece that starts at 1, actually right after 1, because it doesn't include it, and heads to the right. When I put 1 into that equation, I get 3 plus 4, which is 7. The last question is really asking you just to compare the two things you just did. If I want to figure out the limit of the entire function, what I need to know is, does the limit as we go from the left equal the limit as we go from the right? That's really the question that you're looking for. And you can see, looking up above, it didn't. What this is telling you is the one piece stops at a height of 3, and then it picks back up at a height of 7, meaning there's a graph. So visually you would have something like this, where it's coming towards a height of 3, and then it restarts up at a height of 7. Now they're not necessarily flat pieces like that, but it still illustrates the fact that there is a graph. So at this point we say that it breaks our rules for limits, does not exist because it approaches a different height from the left as it does from the right. If you would have got the same answer for the one-sided limits, that tells you limit exists, and it would exist at that number that you got. The second question we're going to look at is a little more generic. We did one like this in class. Now I'm basically saying I want you to guarantee that we do have those limits that exist, that it is continuous. So I have these two equations that represent my piecewise function, and the directions will ask you to find the value of a. We also did a problem in class where you had to find a and b, so it could get a little more difficult than this, in order to make the function everywhere continuous, making sure that there is no gap. The way you do that, in order for that to happen, these two lines have got to be equal at 2 in order for it to be continuous. That the place where x is changing, in this case it's 2. In other problems we saw 3 or 1 like the last one. That is the one place where we might have an issue with continuity, if the limit on one side is different than the limit on the other. To ensure this, I want to know that 2a x squared plus 1, the top line, is equal to negative x minus 3, the bottom line, when x is 2, because that is the questionable point. So plug 2 everywhere you see an x, so we have 2a times 2 squared plus 1 equals negative 2 minus 3. And now it's just a matter of solving a basic linear equation. We get 8a plus 1 equals negative 5, subtract 1, 8a equals negative 6, divide, a is negative 3/4. And there are no restrictions on a as far as it doesn't have to be positive, negative, it doesn't have to be a whole number. Obviously this one is a fraction and negative. We are just looking for that value. The way we make it more complicated is we add another equation in my piecewise function, add another unknown like a b value like we had done in class, and make you do multiple equations where you'd have to solve a system. But this gives you that first level, and you will see this show up multiple times on your Chapter 1 test.